2.7 is step functions, and I believe that you guys have seen these either in Algebra 2 or Algebra 3, but it was probably really, really brief, so it's probably not something you talked a bunch about. Okay, here's our problem. You have D dollars to spend on CDs. The cost of each CD we're going to approximate, we're going to average, is $13. How many CDs can you buy? Make a graph to represent the situation. Okay, before we do the graph, let's make a table. Let's say that we're going to put our D over here, and then the number of CDs I'm going to put as C for my Y coordinate. So let's just throw some numbers in here. I'm going to put in 0 and 10 and 20, all the way up to, let's do $70. You guys figure out how many CDs you could buy if you had those different amounts in dollars. Okay, so obviously if we have $0, we can't buy any CDs, right? And if we have $10, we still don't have enough to buy any CDs. So we'd have 0 in both of these. If we have $20, now we can buy 1 CD. We don't have enough to buy 2. If we had $30, yeah, now we could buy 2, but we don't have enough to buy 3. If we had $40, we could buy 3. 50, is that going to give us enough for 4? No. Okay, so we're still at 3 here. 60 then would be enough for 4. And 70 would be enough for, help me out, is it 5? Okay, so that looks a little weird, right? If we are going to graph this, it's probably going to be helpful to add in a couple numbers in here. We'd hit 1 if we had $13, so I'm going to plug that in. We'd hit 2 if we had $26, so I'm going to plug that in as well. 3 would be at 39. 4 would be at 52, thank you, and help me out with 5. Thank you. So if we graph this thing, it's going to look different than most functions that we've seen. If I put D here and C here for my axes, I can't buy any CDs until I get up to $13. So on my x-axis down here, I'm going to put 13, and I'm going to be at 0 this whole time. But I'm going to put an open circle here because once I get to $13, now I can buy 1 CD. So I have a point up here. $13, I can buy 1 CD. Now, from 13 to 14 to 15, all the way up to $26, like $25.99, that's all I can buy is 1 CD. But once I hit $26, once I have that in my pocket, now I can jump up and I can buy 2 CDs. I can't buy 3 until I get to 39, so if I have $38.99, I'm still at 2 CDs that whole time until I get to 39. Now I can jump up to 3 CDs and so on. And that's going to go to 52. This is called a step function. We can do these in our calculator too, and we'll come back in a second and plug this into our calculator. But again, this is called a step function when you're breaking it up into separate pieces like that, horizontal pieces. Okay, the one thing that we need to know before we can put this into our calculator is this thing right here. A greatest integer function. This is one type of step function. Another name for it is the rounding down function, or sometimes it's also called the floor function. So this is the key right here. It kind of looks like absolute value, but those little brackets, that stands for greatest integer function. Okay, how do you use it? All you do is find the integer that's less than or equal to the number that you're looking at. So let's look at a couple examples to see what that means. Okay, if we had this, This means the greatest integer that's less than or equal to. That kind of sounds like an oxymoron. Greatest and then less than. Okay, you're looking for the biggest integer that's less than or equal to this number. Okay, so what is, if I look at a number line here, I have -2 and I have -3 and -2.23 somewhere right here. The greatest integer that's less than or equal to this number. Less than would be -3. You're rounding down. You're rounding down. Yep. If it's a negative number, yeah, you can think about it like that. So what it is you're going to go down from whatever number you're at, and the next integer, the next whole number, positive or negative whole number, is what it's equal to. Okay, what about this one? It is -1. Yep, because it's less than or equal to, we're already on that integer, so that's just going to be -1. Okay, what about positives are a little bit easier than negatives. What about, whoops. What's this? Just 4. Okay, so let's go back to that graph that we did before and figure out if we can find a function that fits this. Okay, what we did was we took this dollar amount and we divided by what? 13. So I'm going to say that what we're doing here is we're taking the dollar amount that we have and we're dividing by 13, and then we're rounding down. Because if we get a decimal, like if we found out that we could get 2.3 CDs, well, we can't really buy 2.3 CDs. We can only buy 2 CDs. So we're rounding that number down. Okay, let's look at our calculator and put this in here. Okay, so you're going to go into math, over to number, and int right here stands for greatest integer or floor function. So I'm going to select that. And then we can plug in our d, x in this case, divided by 13. And I'm going to change my window a little bit. Let's do, I had 0 to 70 for the dollar amounts. And let's see, the most CDs we had was 5, right? So there's your steps. Okay, the one thing that your calculator doesn't give you is it doesn't tell you where your open and closed circles should be. So if I was graphing this on my paper, I'd want a closed circle here. That's where I jump up to 1 CD. But then I want an open circle at the end, because once I hit this is $26 right here. Once I hit $26, I'm jumping up to 2 CDs that I can buy. Correct. Oh, okay. You have it looks like this. Some of the 83s do that. I can't explain why. It's almost like an asymptote. These don't really have asymptotes, but when they do have vertical asymptotes, they'll draw those in. There's no way to get rid of them. You can put them on the 84s. I don't remember how to do it. I know you can, though, but you can't get rid of them on the 83s. So just kind of ignore those vertical lines. The other thing that this is kind of helpful for is if you go into your table, and I'm going to change how I'm counting here. I'm going to count by ones. You can see when you jump up. So if I have any of these amounts of dollars, I can't buy a CD. But now if I get up to 13, I can buy 1. And I'll have 1 all the way up until I hit 26. And then I hit 2. Okay, anybody have questions about that? So we're going to graph just this, just the greatest integer function. We graphed kind of a form of that on our calculator, but let's do this by hand. One thing I want you to know that this is called, when you have to pick up your pencil, it's called a discontinuous function. Most functions that you guys have done throughout your whole algebra career have been continuous. You can draw the whole thing without lifting up your pencil. Okay, that's a continuous, this one's discontinuous. So let's make a table. Let's put in 0, 0.5, 1, 1.5, 2, 2.5, and see if we can figure out what this thing looks like. And you guys already should have kind of an idea. But you guys find the y-coordinates and then graph it. Okay, I think most of you guys are getting this. The idea is that you're rounding down. Okay, so if I have an integer in here though, like 0, I don't have to round down at all. These are just going to be those whole numbers, 0, 1, 2, 3. The other ones I'm going to round down if I have a decimal on them at all, so it looks like that. So if I have the point, let's just graph some of these on here. 0, 0, 0.50, 1, 1, 1.5, 1. And now the key to this is I have to know where I'm going to jump up. So what's the very last number in here that's going to have a y-coordinate of 0? 0.99. So I'm going to go all the way over to 1, because 1 is where I'm going to jump up, and I'm going to put an open circle there, okay, and fill that in. Same thing here. Go all the way over to 2 and put an open circle. All the way over to 3, open circle. All the way over to 4, open circle. These are just the points that I had on my table. You don't have to have those dots in there. This same thing's going to happen as you go in the negative direction. Okay, so if I just continue this same pattern, here's what my graph looks like. And you do want some negatives to be included as well. Okay. Question then, what is the domain? Are there any numbers that we can't put in for x? No, so the domain would be all reals. Are there any numbers that you can't get out for y? Can't get any fractions or decimals out. So what could we say for our range? All integers, good. No. Domain, yes. Most cases, you're going to have all reals. Your range is really going to depend on what your function looks like, and you'll have to graph it or look at a table to know. If it was plus 2, it would move everything up 2. Okay? But your range would actually be the same. What would change it is like if I had something like this. That's going to spread it out now. It's going to multiply all my y-coordinates by 3. So instead of stepping up by 1 every time, I'm going to step up by 3s. So then you'd say something like integers that are multiples of 3 would be your range. Okay, other questions? All right, the other thing that you're going to talk about then in your homework is the rounding up function. You don't see this as much. Actually, this is the only book that I've seen it in. The rounding down function, or that floor function, is really, really common. This is the exact opposite of what we just did. You just round your integer up. Okay? An example of that would be cell phone companies. Okay? If they're going to charge you for minutes, like let's say I talk on the phone for 5 minutes and 30 seconds. They're going to charge you for 5 minutes, or are they going to charge you for 6 minutes? 6. So they're always rounding your numbers up.